So here's some help with the stacks of kinematic curves. We'll look at some of the even questions. So remember, to go from position to velocity using our mnemonic, we need to find the slope. This slope here is pretty constant, so let's describe it using three adjectives. It's a negative slope, so I'm going to use the word negative. It's a negative slope. I'm going to call it about a medium slope. It's not too steep, it's not too shallow, so I'm going to call it a medium slope. And it's constant. So what we do is we replace the word slope, because the slope of the position time graph is the velocity. So I'll replace that with the word velocity. And I need to draw a negative, medium, constant velocity on this velocity time graph. So if it's negative, that means it's going to go below the zero, somewhere down here. Medium, so it's going to be somewhere, it's not going to be too shallow, not there, but somewhere in the middle, right there. And it's going to be constant. And the way we show a constant velocity is like that. Alright, so now we've got to go from there to there, and once again, using our mnemonic, that is the slope. If you forgot our mnemonic goes like this: XVA. Every time we go in that direction, we look for the slope. So let's describe this slope. This slope is a zero constant slope. So to describe the acceleration, I get rid of the word slope, and that's a zero constant acceleration. So 0 would be right here, and constant would be right along that line. Let's look at number 4 now. Now, this is not a constant slope on number 4, but we still need to find the slopes, the different slopes, as we go from position to velocity. So let's look at three different parts. I want to look at this part of the graph, this part, let's look at 3 spots, and that part. This particular part, I'm going to call that a zero slope. So a zero slope, if I replace the word slope with velocity, that means that's a zero velocity. So right here at this time down here, I'm going to draw a dot right there to represent this slope, meaning a zero velocity. Then at this point right here, we've got, let's use 3 adjectives. That would be a negative, medium, well, actually just 2, a negative, medium slope. So down here, I need a negative, medium velocity, which is going to be right about there. Negative because it's around the 0 line, medium because it's not too close to the 0, not too far from the 0, so it's going to be right there. Then down here, this slope is still negative, but it's kind of a high slope. So a negative high slope would mean that I'm going to draw that right about there. And so this line will be a straight line. Alright? So that's my velocity time graph. Now to go from my velocity time graph to my acceleration time graph, once again, I need the slope, just like I needed the slope here for the velocity time graph. Let's describe the slope. So the slope, let's use 3 adjectives. That's going to be a negative, and let's say medium, and constant slope. We get rid of the word slope, and replace it with the word acceleration. And so a negative constant acceleration would be below the 0 line. That makes it negative. Medium, so it wouldn't be there, it wouldn't be there, it'd be somewhere in the middle, it'd be right there. And it'll be constant, so it'll look like that. All right. Now, let's look at this setup here for number 2. When we go, when we go from position to velocity, remember, we want to find the slope. To go from velocity to acceleration, once again, we want to find the slope. Let's go to velocity to acceleration because that'll go a little faster. So let's describe the slope. All right? So this slope is a medium positive constant slope. So to describe the acceleration, we get rid of the word slope and replace that with acceleration. So medium positive constant. So positive would mean it's above the 0 line. Medium would mean it's not really high, it's not really low, it's somewhere in the middle, right around there. And constant would mean that it is constant like that. We draw a horizontal line. Now, to go back to the position time graph, we have to look at different sections. So right here, let's describe the velocities. At this point, we've got a 0 velocity. Right here, we would call that a medium positive velocity. And right there, we would call that a high positive velocity. And working backwards, because we wanted the slope, first we want to have a 0. So if we're going to move backwards and we want to go up this way, we want to have a 0 slope. Now we can start anywhere because the velocity time graph doesn't tell us where to start the position time graph. So we can actually start this anywhere we want to. And so if we wanted to start right here, that would be fine. So I would start off, like we said, with a 0 slope. Okay, because this told me that I needed a 0 slope. Then for this description, I want to get rid of the word velocity and replace that with a medium positive slope. So up here, I want a medium positive slope. So a medium positive slope somewhere later on in time would look like that. And then here I'm going to replace the word velocity again with slope. So I'm looking for a high positive slope. So later on in time, I would probably get something like that. So I would just connect those lines, and that's what it would end up looking like. So an upward opening parabola, just like that. Okay, let's look at number 4. Number 4 has a velocity time graph, and to go from velocity to acceleration, once again we want the slopes. So right there, I'm going to call that, or actually let's look at the whole description of this line. The description of that line would be a negative. And just to change things up here, let's call that a low constant, because it looks relatively low. Negative low constant slope. Because I'm looking for the acceleration, I'm going to change that to the word acceleration. So I'm going to draw a negative low constant acceleration. So on my acceleration time graph, I'm below the 0 there. Because it's negative. Low means I'm not really far away. I'm not a medium distance away. I'm probably somewhere around there. And because it is constant, I would just draw a line straight across. Alright, now, working our way backwards, again, we want the slope of the position time graph to tell us the velocity. So let's describe these velocities at 3 points. Describe the velocity at that point, and that point. At this point, I would call that a high positive velocity. So here on my position time graph, I'm going to replace the word velocity with high positive slope. Again, the velocity time graph doesn't tell us where to start on the position time graph, so I can start anywhere. This time, I'll start at the origin with a high positive slope. Later on in time, at this point here, I'm going to call that a medium positive velocity. So, up on my position time graph, I need a medium positive slope. So it'll look like that. And then here, let's say that's essentially gotten down to 0. We'll call that a 0 velocity. So up here on the position time graph, I need a 0 slope. So a 0 slope would essentially be a flat line. So that tells me how to draw this thing out. I have a downward facing parabola.